Hey y'all, my name is Cyber Greer, and today I will be talking to you about industrial control system and operational technology cybersecurity, or ICS/OT cybersecurity. So first, we have to start with a discussion of critical infrastructure and describe what it is. So what is critical infrastructure? When you hear the words critical infrastructure, your mind should immediately go to large systems such as water and wastewater treatment plants, electric power grids, oil and gas pipelines, transportation systems, healthcare systems, manufacturing plants, etc. All of these rely on complex control systems that we often don't see, but we rely on them every day and often take them for granted. These systems are vital to national security, public health, and economic stability. Now, you might be asking, why does critical infrastructure need cybersecurity? And that is because things are becoming more interconnected and more of these components are being connected to the internet daily, making them vulnerable to attacks. But to break it down simply, to break down some of the various components of OT/ICS cybersecurity, operational technology refers to the technology that interacts with the physical world. So you can think your pumps, your motors, valves, sensors, PLCs or programmable logic controllers, HMIs or human machine interfaces, and root terminal units or RTUs, amongst other things. Whereas an industrial control system lives inside of operational technology. So ICS refers to the systems that automate or monitor the physical processes that operational technology conducts. And then SCADA, which is another common term you'll hear in this field, is supervisory control and data acquisition, which is a type of industrial control system that's often in use for large geographically distributed operations. And it allows for remote monitoring, which is very helpful. And I've included some key characteristics of OT environments, such as their focus on availability and safety. So when you think about the CIA triad or the confidentiality, integrity, and availability triad of cybersecurity and IT environments, the focus tends to be more on confidentiality and integrity, whereas in OT, it tends to be more on availability because these systems often have to run 24/7. So any downtime could impact finances very hard or impact lives very harshly. So now I'm going to talk about some common ICS/OT security techniques. So the first one we'll talk about is air gapping and network segmentation. So air gapping is essentially a physical or logical separation between networks, especially between IT networks and OT networks. An air-gapped OT system has no direct internet connection, whereas network segmentation creates zones using firewalls and virtual local area networks to isolate parts of the OT network. The second technique I have listed here is allow listing. So allow listing allows only pre-approved software to run on these critical systems. So unlike antivirus, which blocks the known bad, allow listing permits only the known good. The third technique is strict change management, which essentially means that all changes to hardware, software, or system configurations go through a formal process of review, testing, and approval. This is important because ICS systems are delicate, so an untested software patch or update could shut down a factory or damage equipment. Furthermore, many systems are high availability, meaning that downtime is incredibly expensive or potentially dangerous. Next, we have behavioral anomaly detection, which means that systems continuously monitor for unusual patterns in network traffic, commands, or device behavior. So to do this effectively, organizations must use ICS-aware intrusion detection systems, or IDSs, that understand protocols specific to ICS systems. And lastly, we have physical security, which is just the protection of hardware and access points to prevent damage, tampering, or sabotage. So some of the security controls you can have for physical security include badge access, surveillance, locked cabinets and doors, and environmental controls. So I've listed five techniques, and it may sound like they operate in isolation. However, a common and important cybersecurity um, fundamental is defense in depth or layered defense. So each of these techniques works best together. No single control is foolproof. A layered approach creates multiple barriers, so if one fails, others are still in place. You never want to have a single point of failure in cybersecurity. So now I'll briefly cover IT and OT convergence as it is important to the modern OT environment. So convergence has increased because of significant business advantages such as improved monitoring, efficiency, and decision-making capabilities. However, this increased convergence also increases the attack surface because malicious actors can gain access to OT systems by first infiltrating the IT system and vice versa. So this is why network segmentation is so important in OT systems. So what are some examples of an attack on an OT system or critical infrastructure? So some huge examples, infamous examples include the 2010 Stuxnet attack, which attacked Iran's nuclear program and set them back a couple of years. It was brilliantly written malware, and presumed to have been written by the United States government and the Israeli government. And then you've got the 2015 Ukraine power grid hack, which disrupted electricity supply for 225,000 people. And this was presumably conducted by Russian malicious actors or Russian nation state actors, I should say. And then the last infamous one is the Oldsmar, Florida water treatment plant attack, which occurred in 2021, where a group of malicious actors got control of a remote system and attempted to change the sodium hydroxide level in this city's water treatment from 100 parts per million to 11,100 parts per million, which would have been deadly for the people drinking the water. But luckily, the plant operator saw this immediately and changed the values back to their normal values before the water supply was affected. Okay, so now that you've seen some examples, we can go ahead and conclude. So, in conclusion, ICS and OT cybersecurity is a rapidly growing field. Um, ICS and OT cybersecurity protects the everyday systems that we take for granted. And as interconnection increases, it's only going to become more and more important. So we need more frameworks, we need more professionals, and we need more collaboration between IT and OT teams to improve OT cybersecurity to ensure the safety of our future systems. And some ways you can get involved in OT cybersecurity or learn about OT cybersecurity include Mike Holcomb. Mike Holcomb is a legend in this field. If you know anything about OT security, you know who Mike Holcomb is. But he has a free 20 plus hour course on YouTube covering the fundamentals of OT security. CISA, or the Cybersecurity and Infrastructure Security Agency, has free ICS training on their website, and you can get some certifications through them. And then SANS, which is the premier cybersecurity education organization, has a master's degree where you can actually specialize in industrial control systems. So those are some ways you can get involved in ICS and OT cybersecurity. And I hope you learned something from this video. And I hope you have a great day. Thanks for listening to me.